Hello and welcome to another Spaz Kangaroo tutorial. Today I'm going to begin the series on game development in Love2D with Lua. So if you haven't already seen my Lua tutorial series, go watch that now so you have the prerequisite knowledge you need to begin game development. So we're going to be doing game development in a game engine called Love2D. It's a 2D game engine written in C++, but it has Lua embedded for scripting. So you write the actual game in Lua. To install it, all you have to do is go to the download page on the main site and download for whatever version you need. I'm on a 64-bit Mac, so I'll just download that. Okay, so it's downloaded. Open it up, and you will get an application. So to run a Love game in Love2D, you just drag the entire folder onto the Love2D application. So for now, I'm just going to move this to my applications directory. I already have a version, but I'll replace it because this one's slightly newer. And then to run a game, I would open up a Finder window, go to a game that I would want to open. So I will go to one of my games that I've created previously, and I'll name it. You name it with a .love extension. So just name the folder with a .love extension, so that you know that it's a Love game. And open the applications. Actually, I might open this as a separate window. Then you just scroll to the Love2D application and drag and drop on top of it, just like that. Open it, and you will have your Love2D game running. So this is something I've previously made, but we will be developing the game now. To set up your project, all you need is a directory with the .love extension and a Lua file inside called main.lua. You must name it main.lua. Can't name it game.lua or anything like that. It has to be main.lua, and Love will automatically find this Lua file and execute it. So let's actually edit our main.lua file and have it do something interesting. I've named the project directory Invaders because I'm going to teach you how to create a Space Invaders style game from scratch. Let's just create a basic Hello World program, like similar to how we've done Hello World programs in the past. Really simple programs that just show basic functionality. The Love2D game is made up of three main functions. There's the load function, the update function, and the draw function. To do a Hello World program, all we really need is the load and draw function. So function love.load is our main load function, where we put any information in here that gets run initially before the game starts. We have our love.draw, which gets called every time it goes through a frame draw. So every tick, every time it draws, it will call the love.draw function. And inside the love.draw function, we'll say love.graphics.print, like that, hello world, and that's it. What will happen when we run this program now, if I drag it and drop it onto, my applications folder. So let me open up a new window, go to applications, and drag and drop. Come on. It will say hello world in the upper left hand corner, and that's our basic example. So now that I've shown you how to do that once, I'm not going to do it again and again since it's a little bit of a silly process. It takes a little bit too long for a tutorial. So this is how we get our basic hello world program. Really simple. We get the text on screen, and it's fairly easy to decipher. The reason we're not using just a regular print here is because this is a custom print function that is written directly into the Love game engine. So without it, it would print it to the console and not to the window like we want it to. So this is kind of boring. Space Invaders are not going to be made out of text, and we've seen a lot of text previously in this Lua series. So let's actually do something interesting now. We're going to create a rectangle. Yay. We create a rectangle by love.graphics.rectangle, and we have to give it a little bit of information here. We can either have it filled, as in a solid filled rectangle, or we can say line, and it'll just be the wireframe or the drawing around a rectangle. For now, I'm just going to use fill. Then we have to give it the X location of the upper left corner of the rectangle. So we're going to say 10, Y location 10, width 10, height 10. And these are all in pixels. So now when we run it, we get this little box here. Let me make it bigger. We make it bigger by saying the width and height, these last two arguments, will be 100 pixels each. Like so. And now we actually are getting somewhere. We've got a little box that we can draw, and this is actually drawing many times per second. It's drawing as many times per second as 60 times per second. So let's actually make this, since it's redrawing the frame every couple milliseconds, let's actually make the box move. So we can do this by making it increment a variable. So if we have our variable that we put in love.load, so x equals 0, right? And we'll say the x location is here, right? So now it'll say x is 0, it'll stick, and whenever it draws a frame, it will grab the x location, which at this point is 0. But every time we draw the frame, we're going to actually increment x by 1. So x equals x plus 1, like so. And now x will increase every time we draw a frame. And now we have a moving box across the screen, which is pretty cool. So that's kind of neat and everything, but there's still no user input. Let's actually let the user do something. To do that, we're going to actually have to start using the love.update function. So I'm just going to put this right before my love.draw function. Doesn't really matter what order you put it in. When you create the love.update function, make sure you put dt in there, and you'll see what that is later. It's called delta time. It's the delta time variable, so keep that in mind. So what we're going to do is we're going to check that certain keys on the keyboard will or will not be down. So let's say to move to the right, like our box is currently doing, let's say we need the right arrow key. To check that the arrow key is down, we can say if, like we're back to if statements, love.keyboard.is down, and right to say the right arrow key on your keyboard. Then in here we'll say x equals x plus 1, and make sure to remove it from the love.draw function so it doesn't automatically move to the right. Right, so now if we run it, I'm holding the right arrow key down, now I'm letting go, now I'm holding the right arrow key down, letting go. So now we can make our box move only when the user hits the right arrow key. Let's do the same for the left, since that's pretty simple. So else if love.keyboard.is down, left, and x equals x minus 1, because we want it to go the opposite direction. So now we can move right, move left, and if we wanted to do up and down, we'd have to create a variable for y and set the y location in our draw function to y, and add a little bit of if logic, if else if logic in our update function. And instead of x, we use y. Now when we run it, our box moves in all 4 directions. Now I got my y locations mixed up, so holding up actually makes it go down, but that's easy to fix. We just flip the signs here. And there we go. We can now move our box in all 4 directions with just our arrow keys. It's pretty cool. So we've got some user input. We can draw to the screen. The love.update function is what moves the is called every tick in the game. A tick is like once every 60 times. A tick is called every 60 times per second. So every time the frame is redrawn, it runs love.update first, then it draws the frame, then it runs love.update again, then it runs love.draw, and so on and so forth. Let's add some color to this, shall we? The rectangles being white is a little bit boring, so let's make it blue, perhaps. You can do that by saying love.graphics.setColor, and we have to give it a few set of numbers, RGB, A. The A is optional. If you've ever used Photoshop or GIMP, you've probably seen how when you create colors, you can set the individual value for the amount of red, green, or blue in the color. In Love, the game engine recognizes colors by numbers. So if we say 0, 0, 0, as in red is 0, green is 0, and blue is 0, we get black, because the lack of all colors is black in the RGB color scheme. If we say 255, this is the greatest a color can be, we get white, because red is 255, green is 255, and blue is 255. But we want it to just be blue, so we'll say red is 0, green is 0, and blue is 255, which will give us the maximum amount of blue we can possibly draw. So if we do this now, we get our nice blue rectangle, which we can still move around with our arrow keys. Let's actually make some gameplay now. So since this is going to be Space Invaders, our player isn't able to move up and down, not in the original Space Invaders anyway. So we can remove this logic here and remove the Y location here, as well as right here. We're going to set it to 600. The Y location is 600, so they spawn near the bottom. Oops, that's a little bit too far. It's off the screen. Maybe 300. There we go. That's closer to the bottom. Maybe 400. Perfect. So we have our box so it can move back and forth. And for now, let's make it a little bit shorter. So the X location is fine. Well, actually, let's set it to 80. Maybe we'll make it a little thinner too. Set the height to 20. Run it. And there we go. We've got a little rectangle now. And let's add the ability to create bullets. So the way we're going to create bullets for now is we're going to store them in a Lua array that the player will know about. So before we do that, let's actually clean up our code a little bit and structure it in a way that will make more sense. So before all this code here, we're going to actually define a table called player. If you remember tables from the Lua series that I did previously. If not, go ahead and review that, because this is going to be fairly important continuing forward. We'll have an X location for our player. .x equals 0 for now, because we always start at 0. And we'll have a player.bullets table, which is going to be empty. So we can access each of these in our table by saying player.x, player.bullets, so on and so forth. We can actually stick this in the love.load function if we want to, and delete this x, this random x here. And every time we have x in the code, we'll have to say player.x, player.x plus equals 1, player.x, player.x minus 1, and our x right here. We could just leave the x around, but as we go forward into this tutorial more, it's going to be more complex. The code is going to become more complex. It's going to be a little bit difficult to keep track of everything. So we don't want an X location of a player to be confused with the X location of a bullet, because that will be very difficult to debug. And if we just keep everything in its own little table, it'll be a little bit easier to handle later on. So, and once we add enemies, that's even more X locations, and it just becomes very difficult after a certain point if you don't have your code structured in a way that's easy to figure out what's what. So our code still works because we said player.x everywhere. If it blew up and said no variable defined x like this, you can look at the line number, which is in this case 19, go to that line number and say, oh, this isn't supposed to be x, it's supposed to be player.x. Okay, so now we've got our code working, moves back and forth, we're good to go. Now what we're going to do is actually create a bullet inside the player object. We'll create a function for our player called player.spawnBullet or something like that. Maybe player.fire. So it'll be like a bullet fire function. So the player.fire function, player.fire is a function, so we have to say function. So we're just defining our function in our table. Make sure to end it so you don't have run into a syntax error. And in here we're going to say player.bullets. We're going to say table.insert player.bullets, and we're going to insert a bullet. But we should actually create that bullet now. So just type bullet for now, and then above it place bullet equals that is an empty table. So our bullet is going to have a few attributes. It's going to have an X location equals, we'll start at the player's X location, and it's going to have a Y location. In the player Y position is 400, so you can see right here. So we have our bullet X, we have our bullet Y, and we're going to insert that bullet into the player.bullets table. We're not currently enabling the user to do anything to fire, so this is kind of useless. So let's actually allow the user to call this fire function now. So if love.keyboard.isDown space, actually wait, no, I think it's just a space. You just put a space inside those quotes. Then we will say player.fire. And this will not do anything at the moment because we actually don't have any logic to handle this. So if you hit space, it really won't do anything. So in our update function, well, in our draw function, let's actually draw those bullets. So for I in pairs player.bullets do, oh whoops, sorry, I comma v in, you can actually say underscore v because we don't care about the index, I mean the key. So for v in player.bullets, v love.graphics.rectangle, say fill, it will be the bullet, so v, not bullet, v dot x, v dot y, and the width will be, we'll say 10 and 10, so it'll just be a little square dot. So now when we say plus and move away, we'll see these bullets that aren't moving, aren't doing anything interesting, but at least we're creating these bullets. So close that window. The first thing I'm going to do is I'm actually going to make them a different color so we can differentiate them from the rectangle. I'm just going to make them white because that's the color they are in Space Invaders. So 255, 255, 255. Actually in the original I think everything was white, but we'll actually add some color because why not? So there we have a bullet. If you hold it down, it creates this line of bullets next to each other. So we can now differentiate our bullet from the player, but the bullets aren't going anywhere and they're not disappearing after a moment. So let's make these bullets move now. In our love.update function, we're going to say for underscore comma v, because we don't care about the key, in pairs player dot bullets do, and we're going to say bullet, no, not bullet, sorry, v.x equals v.x plus 1. Oh, sorry, v.y equals v.y plus 1. So we want it to move up, which is our y location. So we're saying for every bullet which gets placed in v, in pairs player.bullets do that. To make this more clear, we can actually name this, actually, yeah, we'll leave it v, all right? Or we can name it b because it's a bullet. All right, and we can do the same here, just to make things a little bit more clear for yourself. All right, so now they fall, which is cool because they're moving, but they're going the wrong direction. That's just because I added one, and I'm supposed to actually subtract one to make it go up. So now when I do it, it goes up, which is pretty cool, actually. But they're kind of slow at the moment. I'd rather see them go a little bit faster. So instead of bullet equals instead of b.y equals b.y minus 1, we're going to see b.y equals b.y minus 10. So now it'll move 10 pixels every tick rather than just 1. And now we're seeing some really cool bullet motion. That looks kind of neat. But these aren't clearing up. So if we play this for a while, we're going to eventually start running out of memory because the computer will be calculating the bullets that are thousands and thousands of pixels away but are still moving, and it'll still be like, oh, I got to draw these, but it doesn't. So let's add a little bit of cleanup code for our bullets so that the ones that are far enough away are deleted from the table. So in this case, we're going to say I pairs because we want the index of the bullet. We're going to bring the underscore, turn the underscore into an I because we actually care about it now. So we want the index of each bullet, and we can say if b.y is greater than, is less than 0, because 0 is the very top of the screen. So if it's less than, actually we'll say negative 10 because we can let it go a few pixels past and then destroy. Then we're going to say table.remove. Remember our table.remove function from base Lua. Table.remove player.bullets I. So we're going to say remove this bullet if it's past negative 10. So this isn't something that we can really see, but it's actually deleting it now. To see it, let's just say, we'll say positive 10, and then we'll see it die before it reaches the end. Oh wait, is it actually doing that? It might not be doing that. Is less than 100. But yeah, there it is. So you can see it's dying as soon as it reaches that 100 mark, which is why it's kind of like hitting a plateau right there, because it's removing it from the table and then it's not having to draw it anymore. Alright, so we can say like negative 10, so we don't actually see it deleted, and then it will appear as if they're going off forever into infinity, but they're really not, they're just getting deleted. Alright. One thing that's been bothering me for a couple minutes now is the fact that these bullets, well, there are two things really. One is we can fire as like a load of bullets at once, and we really want to have a little bit of a distance between these bullets firing. And the other is that it's not in the center of the player. It's kind of right around here, which is at the corner. And in Space Invaders, it's at the middle, right here. So let's actually offset it so that it appears in the right spot. So player.bullets, blah blah blah, and instead of the X location being the player's X location, it's going to be the player's X location plus half of the player's width, which in this case is 80. So half of 80 is, oh wait, is that right? Yeah, that's all right. Half of 80 is 40. And now when we fire it, it's closer to the middle. The issue is we have to also offset it by the half width of the bullet, So it's actually going to be closer to 35. And there you go. It's now going straight down the middle of the player. Now for this, to prevent bullets being fired at an infinite rate, this is actually a little bit more difficult. We've got to use timers. So we're going to say if the time is greater than 1, we're still in cooldown for the player's bullets. When we fire the gun, we'll have to check the last time a bullet was fired. So player.last time, last bullet, we'll say, is going to be every time we fire it, we're going to have to say player.last bullet. At the beginning, it's 0 because our last bullet was never created. Actually, what we're going to do is we're going to have a countdown. We're going to say cooldown equals, we'll say 200 ticks. We'll say every 200 ticks cooldown is done. That might be a little bit too much. We'll say 20 ticks. Every 20 ticks cooldown is done. So every time the player fires, player.cooldown equals 20 because it just fired and has to delete to 0. And then in our love.update function, we're going to say player.cooldown equals player.cooldown minus 1. Right? If we run this now, it won't do anything because we're not adding any logic to our bullet fire function. So in our bullet fire function, we can say if cooldown is greater than 0, then actually that's wrong. If it's less than or equal to 0. So our cooldown is now 0, which less than or equal to 0, which means we can fire a new bullet. If it's greater than 0, that means we still gotta wait so many ticks. Oops. Main line 7. Here we are. We've hit a syntax error. Let's see what the problem is. I just said cooldown. It's supposed to be player.cooldown. So now when we do it, it has to wait 20 ticks between each time it can fire a new bullet, which is exactly what we want. So now we can't max out our bullets fired per second. If you want to leave that in, you can, because it kind of looks cool, but I'm going to try to stick a little bit closer to the original in Space Invaders. And the cool thing about this is even if the player mashes the space key, they can still only fire once every 20 ticks. So it kind of limits any sort of cheating. All right, so let's just do a few more things before we wrap this up. For one, I want to see the player move a little bit faster. So what we could do is we could just replace each of these with a number higher. We could set it to 10 or 5 or 20, whatever we want. But I'm actually going to have a variable that we can use in its place, so we don't have to change it every time we want to change the player's speed. So player.speed, we're going to just create a variable called player.speed. We're going to say it equals, I don't know, let's say it equals 10. Whoops. And then every time we add one or remove one to move to the right or left to the player's X location, we're just going to say player.x equals player.x plus player.speed, and same for player.x equals player.x minus player.speed. Now when we move around, we're a little bit speedier, which makes playing Space Invaders a little bit easier as well. All right. Final thing is I just want to move this the location of the player down more towards the bottom because he's up a little bit too high still. We'll say through trial and error, we'll say, let's say, what was it before? 400? We'll say 500. Okay. That's a little bit closer. Let's say 550. That is the bottom. That's the very bottom. Good. But our bullets are still firing from this location up higher above. Why is that? Well, we never actually assigned this to a variable, so it's still firing from a Y location of 400, which is kind of stupid because our Y location has changed. So even though we're not going to change our player.y variable in the actual game at the moment, we may make him move up later possibly for some reason. But for now, we're just going to set it to a variable, so that way if we ever decide to move the Y location to a different spot, perhaps the level requires it, we can change it more easily in our code. So instead of assigning it to an absolute value or magic value of 400, you never want magic variables, values that make no sense. You always want to have a descriptive variable name. You say player.y, and for drawing it, we say player.y. And now, in our draw function for the player, so let me just comment this a little bit. Draw the player. And here we're drawing bullets. Alright, so now when we run it, our Y location is near the bottom, and when we fire, it fires from the bottom. Alright, so that's all we're going to cover in this tutorial. Next time we will start adding enemies, we will do some physics, and maybe we'll add a score counter. So make sure to stay tuned for that. Make sure to subscribe so you don't miss it. Like this video. Let me know in the comments if you found this helpful. If you need help with anything, I'll be happy to help out. And if you want to see any other features added to the game other than the ones I've just mentioned. So let me know in the comments, and we will see you all later.